Today again we will start the same exercise 3.2 from indefinite integral. In that, integrate the following function with respect to x. So cos 3x minus cos 4x upon sin 3x plus sin 4x. So here the function, let I is equal to the integral of cos 3x minus cos 4x upon sin 3x plus sin 4x. Now as I told you, use the formula cos c minus cos d upon sin c plus sin d. Okay, so after using this formula you will just say 2 cos c minus cos d is 2 sin c plus d by 2 into sin c minus d by 2, and sin c plus sin d is 2 times c plus d by 2 into cos c minus d by 2. So you get this 2 will cancel, and this sin 7x upon 2 into upon sin 7x by 2, this also will cancel, and what you will get sin 4x minus 3x is x, so sin x by 2 will remain, and at the denominator you will remain cos of minus x by 2, but cos of minus theta is only cos theta, so there is no problem for minus sign. I is equal to integral of sin x by 2 upon cos x by 2 is tan x by 2, and the integral of tan x by 2 we know that log of modulus of sec x by 2 upon 2, as here the value of a, tan of a into x, and a is 1 by 2. So while finding the derivative we are multiplying that constant to the derivative, but in integration we are dividing the constant a. So simplify. The integral is 2 times log of modulus sec x by 2 plus c. The next example is 1 upon sin x cos x plus 2 cos square x. So let I is equal to 1 upon sin x into cos x plus 2 cos square x dx. So divide numerator and denominator by cos square x. You get 1 upon cos square x is a sec square x. Now here if we separately divide, one cos will cancel, and here sin x upon cos x is tan x, and here this cos square will cancel. So you get sec square x upon tan x plus 2. Clearly if you take the derivative of this denominator tan x plus 2, its derivative is sec square x. So to use the substitution and simplification, integral of 1 upon t dt. So its integral is log of t plus c. But what is t? Put that value of t in this integral, you get I is equal to log of modulus tan x plus 2 plus c. The second example is cos x upon sine of x minus a. So let I is equal to cos x upon sine of x minus a dx. So add and subtract a at the numerator. So here x minus a plus a. So that I will, one of the angle is x minus a and other is a. So I will use cos of a plus b formula. Cos a plus b is cos a cos b minus sin a sin b, as here. Then what I will do, I will divide each of these term by this sin x minus a. Okay, then cos of x minus a upon sin of x minus a is cot x minus a. Cos a is a constant, and here sin x minus a upon sin x minus a will cancel to each other, and only sin a will remain. Take the separate integral. This cos a is a constant, so we can take it outside. Here will be the integral of only cot of x minus a. And here sin a is also constant, so we can take outside the integral of x dx, which is x. So integral of dx is x, and integral of cot x minus a is log of modulus of sin x minus a. So simplify, you get the answer I is equal to cos a log of modulus sin x minus a minus x times sin a plus c. Integrate the following functions with respect to x. Sin of x minus a upon cos of x plus b. Okay. What we will do? We will add the numerator b plus b minus. So after adding b, add and subtract b, so we get sine of x minus b minus a minus b upon cos of x plus b. So in numerator, we will use the formula sine a minus b is sine a cos b minus cos a sine b. Then we will divide the numerator separately by this cos of x plus b. Here sine x plus b upon cos x plus b is tan x plus b, and here this term will cancel. So cos of a minus b is a constant, so we have to take the integral of tan x plus b. Here is also sin a minus b is a constant, so integral of dx. So integral of dx is x, and integral of tan of x plus b is log of sec of x plus b. So the integral of the given function is cos of a minus b into log of sec x plus b minus x times sin of a minus b plus c. Whenever you see such type of examples, whatever the angle present at the denominator, that type of angle we have to adjust in the numerator and use the formula sin a plus minus b or cos a plus minus b. Look at this example. Sin x plus 2 times cos x upon 3 times sin x plus 4 times cos x. So here, this is the actual method to solve such type of examples. Okay, you keep in your mind that the example which is of the form sin a sin x plus b cos x upon c sin x plus d cos x. Whenever you see such type of examples, we have to use this formula. Numerator, this is numerator. We are writing numerator using the denominator. How? Numerator is equal to a times denominator plus b times derivative of the denominator. So a times denominator plus the derivative of the denominator is 3 times cos x minus 4 cos x minus 4 sin x is the derivative of the denominator. Now we will multiply this factor by a and this factor by b. Then we will collect the like terms. Sin x in one bracket, cos x in another bracket. Take the common, and then we will equate the coefficients of like terms. So here is sin x, here is also sin x. So 3a minus 4b is 1 and 4a plus 3b is 2. Okay, so we are equating the coefficients of the like terms. Then we have to solve these two equations simultaneously, so we'll get the values of capital A and capital B. How? So we will multiply the second equation by 3 and the first equation by 4. The second equation by 3 and the third equation by 4, so that we get and add them. After adding, you will get 25a is equal to 11. So a is equal to 11 upon 25. So we will put this value of a in the equation 2. So 4 times 11 upon 25 plus 3b is equal to 2. So after simplifying, you will get b is equal to 2 upon 25. So now you have the value of a as well as the value of b. Using these two values in our equation, you get sin x plus 2 cos x is equal to 11 by 25 into 3 sin x plus 4 cos x plus 2 by 25 times 3 cos x minus 4 sin x. So what we will do? We will replace our numerator in the integral by this term. Then we will divide the numerator by separately our denominator. So we will reach to this step. Now here this will cancel and here you will get only 1 dx. And here the term is in the form of d by dx of 3 sin x plus 4 cos x upon 3 sin x plus 4 cos x. So here I can use the formula f dash of x upon f of x. F dash of x upon f of x is log of f of x. Okay, so this is the integral of the given function. Now Instead of doing like this, I have another method for this integral, the second integral. What I will do for the second integral, I will use the substitution method. How? I will put this denominator 3 sin x plus 4 cos x is equal to t. So once I obtain the differential, I will realize that the numerator is, I can replace it by dt. So I get I is equal to integral of 1 upon t dt. But its integral is log of modulus of t plus c. So log of modulus of t plus c. So I get 1 upon, so what is the value of t? T is 3 sin x plus 4 cos x. So put that value in this file. You get log of 3 sin x plus 4 cos x plus c, which is we have obtained over here. So there are two ways. You can use the substitution as well as you can use the formula f dash of x upon f of x dx. So 1 upon 3 plus 2 tan x. Now this tan x can be written as sin x upon cos x. And after simplifying, you will get cos x upon 2 cos x plus 3 sin x. Now here it is in the form of a sin x plus b cos x upon c sin x plus d cos x. So again we will here we will express the numerator is equal to a times denominator plus b times derivative of the denominator. Okay, so put that values, then multiply by a and b, then taking the like terms cos x, coefficient of cos x in one bracket and coefficient of sin x in another bracket, then equating the like terms of this equation, then we get 2a plus 3b is equal to 1 and this 3a minus 2b is equal to 0. From the second equation we obtain b is equal to 3 by 2a. We will put this value in our equation number 1. So after simplifying that equation number 1, we get a is equal to 2 upon 3. So we put this a is equal to 2 upon 13 in equation number 3. We get the value of b as 3 upon 13. So from these two values, I can write the numerator cos x as 2 upon 13 times 2 cos x plus 3 sin x plus 3 upon 13 times d by dx of 2 cos x plus 3 sin x. So replace the numerator by this term and separately divide by the denominator. You will reach to this step. Here this cancel to each other. You get in 2 by 13 into integral of 1 dx plus 3 by 13 into integral of d by dx of this upon this. So here I am going to use f dash of x upon f of x. You can use substitution. 2 cos x plus 3 sin x is equal to t. So the numerator and this dx will replace by dt. So 2 upon 13x plus 3 upon 13 times log of modulus of 2 cos x plus 3 sin x plus c is the integral of the given function. Now this I is equal to 4 e raised to x minus 25 upon 2 e raised to x minus 5 dx. Here also the any example which is of the form a e raised to x plus b upon c e raised to x plus d. For this also we are going to use the same method. We will express numerator as a times denominator plus b times derivative of the denominator. Then what we will do? We will equate the like terms from the both the sides. The coefficients of the like terms 2a plus 2b is equal to 4 and minus 5a is equal to minus 25. So 2a plus 2b is equal to 4 and minus 5a is equal to minus 25. We get a is equal to 5. So put a is equal to 5 in the one of the equation. You get b is equal to minus 3. So by this way you can express the numerator as 5 times 2 e raised to x minus 5 plus minus 3 times d by dx of 2 e raised to x minus 5. So put the values of a and b in this equation. So by this way we have expressed the numerator. Now what we will do? We will replace the numerator in the given integral by this term. Then we will divide this 2 e raised to x minus 5 separately and we will get this term. Here these two terms will cancel each other and you will get 1 dx. And here it is in the form of f dash of x upon f of x. F dash of x upon f of x. You can use substitution. 2 e raised to x minus 5 is equal to t, or the formula integration of f dash of x upon f of x is equal to log of f of x plus c. So 5x minus 3 times log of 2 e raised to x minus 5 plus c is the integral of the given function. Now this is another example. 20 plus 12 e raised to x upon 3 e raised to x plus 4. Look at this. It is also in the same form, a e raised to x plus b upon c e raised to x plus d. So here again we have to use the same formula. Numerator we are expressing using the denominator, a times denominator plus b times derivative of the denominator. So what is numerator? Numerator is 20 plus 12 e raised to x. And what is denominator? 3 e raised to x plus 4. Now what is the derivative of the denominator? It is 3 e raised to x. Okay, derivative of the denominator is 3 e raised to x. Now here after multiplying a inside this bracket, then I am combining the term e raised to x which contains e raised to x. So 3a plus 3b into e raised to x plus 4a is as it is. So by again equating the like terms from both the sides, that is coefficient of e raised to x is equal to 12 and 3a plus 3b, and the constant term is 4a and here is 20. So I get a is equal to 5. So I put a is equal to 5 in the first equation. Simplify it, I get the value of b as minus 3. So I can write the numerator as 5 times 3 e raised to x plus 4 plus minus 3 times derivative of this 3 e raised to x plus 4. Use that in our integral and separately divide by 3 e raised to x plus 4. This term will cancel, you will get integral of 1 dx, and here the term, the integrand is of the form f dash of x upon f of x. Its integral is log of f of x. So log of 3 e raised to x plus 4 plus c. Okay, now again we will stop here. This is our third lecture for exercise 3.2. Now we will again meet once for on this exercise 3.2 only.